Day 3 of Unit 9 in Transformations, we're going to be talking about reflections. A reflection is a transformation that uses a line that acts like a mirror, with an image reflected in the line. The mirror line is the line of reflection. Okay, and reflections have these properties that I have listed here. Okay, so basically what we have here is we have triangle ABC over here, and this is the pre-image, and it was reflected across line M. This is the line of reflection to obtain the pre-image over, the image over here of triangle A prime, B prime, C prime. Okay, so here are some of the properties. If point A is on line M, then the image of A is itself. So A would equal A prime. Okay, all right, so if point B is not on line M, then M is the perpendicular bisector of segment B, B prime. Okay, so right here, B, B prime, this segment, all right, the line of reflection here is the perpendicular bisector, meaning that you're going to have this segment right here. Is going to be congruent to this segment over here. That's congruent to that. Okay. All right. So also reflections preserve distance and angle measures, meaning that reflections are also isometries. Okay, let's go look at a GeoGebra example. Oops. Maybe. Okay, so looking at this reflection activity, you can reflect in a vertical line or horizontal line or any line actually. So looking at this is a reflection in a vertical line where the y-axis is the line of reflection here. It's reflected equally across both lines where this is your line of reflection, which is the mirror line. It's the same distance from this side to this side. Okay, and you can make this smaller, which this would be reflected across the line x equals -3. And here we have a reflection across the line x equals 3. Okay, it's the same distance from the pre-image here to its image here. Okay, the distance between the line of reflection and each object is the same. All right, let's look at a horizontal line of reflection. Okay, this is using the x-axis as a line of reflection. So again, this pre-image was taken and flipped across the x-axis, and it's the same distance from the pre-image to the line of reflection as it is from the image to the line of reflection. And again, you can change this, make it closer, make it further away. So like here we go, our line of reflection here is, if I can get it there, is y equals, I'm trying to do y equals -2, that's close enough. Okay, so this is our line of reflection. So again, our pre-image is the same distance to our line of reflection as our image is. And let's look across the line y equals x. Remember, this is the diagonal line that goes right through the origin, that line right there. Okay, so this is a reflection across the line y equals x. Okay. Then we can do a free line, or you could do any diagonal. And you just keep turning it around. Okay, so going back to our notes, let's look at a couple examples. Okay, so this says graph the given reflections. Right, you have point H, which is at 0.22. And we need to reflect it in the x-axis. Okay, so this will be our line of reflection. So remember, our pre-image is going to be the same distance from the line of reflection as our image. So if we're 2 up from the line of reflection here, our image is going to be 2 down from it on the other side. Okay, so we have H prime right here. Okay, now looking at the other one we were given. We're given G, which is at point as coordinates 5, 4. Okay, so let's graph that one. So 5, 1, 2, 3, 4. All right, so here's point G. Okay, and our line of reflection is a line y equals 4. Okay, so this line, let me draw it for us real quick. Let's draw a dashed line, make it red. Okay, I'm gonna have to move it up some. Okay, so this line goes through 4 on the y-axis. All right, so what do you notice about point G? It is on the line of reflection. And whenever you have a point that is on the line of reflection, the pre-image and the image are exactly the same. It doesn't move. So not only is that G, G prime is also in the same spot. Okay, so because it was on the line of reflection, G prime and G were the same. G and G prime are the same. Okay, so let's look at number 2. I want you to pause the video, take a moment, work number 2, and then you can look at your answer. Okay, so looking at number 2, all right, W is at negative 3, 3. So 1, 2, 3, 1, 2, 3. All right, so here's W. All right, we're going to be reflecting it in the y-axis. So our line of reflection now is the y-axis. Okay, so remember, we're going to be reflecting across it. So we'll be going over here to the right. We're going to be the same distance away from our line of reflection on our image as we were on our pre-image. So we're 1, 2, 3 away from the line of reflection here. So we'll be 1, 2, 3 away from the line of reflection here. So W prime will be right here. Okay, so Z is our next one. Z is at 1, 3, right here. Okay, and it's going to be reflected in the line x equals 1. So again, I'm just going to draw a quick line right here. And if you notice, Z is also on top of its line of reflection. So if your pre-image is on the line of reflection, your image will be the same one. So Z and Z prime are the same. Okay, so looking down here, it says reflections in the coordinate axis have the following properties. If a point xy, positive x, positive y, which would be in the first quadrant, is reflected in the x-axis, which means it's going to flip down, it'd be down here in the fourth quadrant, its image is the point x, negative y. Okay, and if point xy, again in the first quadrant, is reflected in the y-axis, so it will be flipped over here to the left, its image point would be negative x, positive y. Okay, so looking at the next thing, talking about lines of symmetry. So a figure in the plane has a line of symmetry if the figure can be mapped onto itself by reflection in the line. Okay, so the image must be the same on each side of the line of symmetry. So looking at this polygon that we have right here, okay, so sorry, this polygon is a pentagon and it has one line of reflection going through the center. It is a regular polygon, so it actually has more than that. Let's look at this. It actually has one here. And let me fix this real quick. Sorry, guys. Okay. And it has one here. I'm not getting these perfectly spot on, so I'm so sorry. And it also has one here. And it helps if those are red, so you can see them. And then the last one is here. Okay, so each one of those is a line of reflection, meaning it divides the polygon exactly the same on each side of that line of symmetry. Okay, so if you were to fold it on that line of symmetry, then both sides should fold on top of each other. All right, so this pentagon actually had, let's see, 1, 2, 3, 4, 5 lines of reflection. Okay, so I will write that down. It had 5 lines of reflection. Okay, the square had 4 lines of reflection. So if you have a regular polygon, you're going to have more lines of reflection or lines of symmetry. That's what that should say, lines of symmetry, than you would in irregular. It should say symmetry. And that should say symmetry. Okay, so looking at these examples here, all right, we're going to determine the lines of symmetry in each shape. So looking at the first one, the octagon, that is a regular octagon. So already I know how many it's going to have. It's going to have 8 because the regular, all sides are the same. Okay, so all we're going to do is we're just going to draw the lines of symmetry and see if I can get a better. Okay, so first of all, I'm going to draw one here where it just cuts it in half. It wasn't exactly in the middle, but you get my point. All right, so this side over here is the same as this side over here. Okay, so the next one also cuts it in half. The side up here is the same as that side right there. I can cut them in half in the middle of each side so that this half will be the same as that half. Same thing here. This half will be the same as this half. Now let's look at the corners. If I were to slice this in half from here to here, it would be the same on this side and that side. So I can do corners as well as the sides. And then this one. Okay, so those are all the lines of symmetry for that one. So there are 8 lines of symmetry there. Okay, so I'll pause the video and y'all do the lines of symmetry for numbers 2 and 3. Okay, the lines of symmetry for number 2, you have one going here. Oops. And you also have one going here. This is not a regular polygon. All the sides aren't the same. This one only has 2. Okay, looking at the third one here, this one is a regular polygon. Okay, so it is a hexagon, so it's going to have 6. So have one here, here. There we go. Back in the middle now. Okay, you have one here, here. Hard to get them exactly in the middle drawing on this. I'm sorry. That's better. Okay, and then so I got the corners. Now I got to do the sides. And here. Okay, so that is 6 lines of symmetry. Okay, so let's look down here at the review. All right, so you're given the points for J, A, and G. So you need to graph triangle JAG and its reflection image as indicated. So let's look at actually pause the video right here and y'all can do these by yourself and then for numbers 1 and 2, and then we'll come back together and look at the answers. Okay, so for number 1, we're going to plot JAG. All right, J is at 1, 3. So here's J. A is at 3, 4. It is here. All right, G is at 2, 1. So it is here. So this triangle looks something like this. Well, you get the point. Okay, so then you had to reflect it into the y-axis. So the y-axis is your line of reflection. So you're going to take it from over here, and you're going to flip it over here, and you're going to end up in quadrant 2. Okay, remember, you're going to be the same distance from your line of reflection on for the image as you were for the pre-image. Okay, so let's look at what that looks like. So J prime will be at negative 1, 3. All right, A prime will be at negative 3, 4. All right, and G prime will be at negative 2, 1. Okay, so here is the reflection. Okay, let's look at number 2. All right, so we had to graph JAG again. So let's go ahead and graph that. Okay, so we have J, which was at 1, 3. 1, 2, 3. All right, A, which was at 3, 4. And G, which was at 2, 1. Okay, so this time you had to reflect it in the line x equals negative 1. Okay, so we're going to draw that line, which is right here. Okay, so there's your line of reflection, and you need to flip it over. So you're going from up here, you're flipping it down here. You're going to end up down here in the 4th quadrant. Okay, so remember, you're going to be the same distance away for your image as you were for your pre-image from the line of reflection. Okay, so you have, I'll start with G because it's right here. All right, you're 1, 2 away from it up here. So you're going to be 2 away from it down here. She'll be right there. So here's G prime. All right, J was up here. It was 1, 2, 3, 4 away. So it will still be 4 away. So 1, 2, 3, 4. That is J prime. A prime is 1, 2, 3, 4, 5 away. So it will still be 5 away. So 1, 2, 3, 4, 5. So here is our reflection. Okay, so let's look down here. We know that reflections are isometries, so it preserves the distance and the angle measures. So when you have a reflection, the pre-image and image are going to have the same measurements. So knowing that, I want y'all to pause the video and go ahead and set up an equation to solve for x, y, and z. Okay, so let's look at x. You have 3x's right here, and it corresponds with this right here that is 4. So your equation is going to be 3x equals 4. So x is 4/3. Okay, so looking at the next one, let's do y. So we have 1/2 y minus 10 right here. It corresponds with 8 up here. So our equation is 1/2 y minus 10 equals 8. If you add 10 to both sides, you're going to get 1/2 y equals 18. To solve for y, you multiply both sides by 2, so you get y equals 36. Okay, so now we need to find z. Right here is 2z minus 1. It corresponds with 5. So our equation is 2z minus 1 equals 5. So you're going to add 1 to both sides. So you get 2z equals 6. Divide both sides by 2. So z is 3. Okay, so that wraps up reflections. The next thing we'll be talking about on day 4 will be rotations.